Namaskar everyone. Welcome to this lecture on Symon's rain gauge. My name is Sumit Kumar and today we are going to explore one of the most widely used manual instruments for measuring rainfall. Let's take a quick look at what we will covering in this lecture. First, we will start with a general overview of rain gauge and their different types. Then we will dive specifically into Symon's rain gauge, which is the focus of this video lecture. Next, we will break down the components of Simon's gauge in detail. Then one of the most crucial part, which is measurement of rainfall. After that, we will also discuss how the gauge is installed and protected to ensure accurate measurement. Then we will learn how the rainfall data is reported. A rain gauge, also known as ombrometer, pluviometer, odometer, or hitometer. Uh, it is a meteorological instrument designed to collect and measure the amount of rainfall. Collect and measure the amount of rainfall. These instruments help us quantify rainfall in a standard units, typically in millimeters. Sometimes centimeter or inches are also used depending on the region or convention. Here, in this figure, rainfall intensity of 35 mm per hour means if the rainfall is occurring and the rainfall is stored in a 1 meter of 1 meter flat surface for 1 hour. For 1 hour. If the rainfall is collected in this area of 1 meter by 1 meter, which is flat, then the depth of water will be 35 mm. That is called rainfall intensity of 35 mm per hour. Rain gauges are broadly classified into two main categories, non-recording type and recording type. Here in this video, we will focus on the non-recording type rain gauge. This rain gauge collects rainfall in a container. Rainfall collect in a container and provide only total rainfall over a specific period of time. But it does not give the rainfall intensity. It does not give the rainfall intensity. This type of rain gauge does not say or comment about the rainfall intensity, but it gives only the total rainfall over a period of time. The observer manually measures the collected water. In India, this type of ground recording type, which is also named as Simon's rain gauge, is used by the Indian Meteorological Department. The non-recording type rain gauge gives a continuous automatic record of rainfall over a time, including variation in intensity. This recording type rain gauge will tell when the rainfall starts, when it stops, and what the intensity of the rainfall at different duration. Tipping bucket type, weighing type, siphon or float type are the examples of recording type rain gauge. The Symon rain gauge is a standard non-recording manual rain gauge, widely used for measuring daily rainfall. It was invented by a British meteorologist named George James Simons. It collects rainwater via a funnel. Here, this is funnel. We will see the figure of rain gauge or schematic diagram of rain gauge in the subsequent slide. So, in the Simons rain gauge, the water is collected via funnel into a bottle for total accumulation. The Indian standard codes 52254986 4849 tells about the Simon's rain gauge. There are various spare parts of our rain gauge, but here we will mainly focus on a collector, bottle, base, and measuring cylinder. The topmost part of the rain gauge, this topmost part of the rain gauge is called collector. When the precipitation or rainfall intercept in the collector, then the rainfalls goes through this funnel and through a outlet pipe it discharges into the bottle. This is bottle and this is funnel. And masonry or a concrete structure of dimensions 600 by 600 by 600 mm is constructed to keep this rain gauge. So three component we have seen in this figure. These two figures are taken from the Indian Standard 5225 and 4896. 4986. So here in detail, if we talk about this connector, the collector is exposed upper part that intercept rainfall. This is also called collector funnel assembly. The inner surface of this collector must be smooth with adequate strength and watertight arrangement. At the bottom, it narrows into a funnel outlet pipe which extends inside the bottle. And once the water is stored in the bottle, it is discharged into a measuring cylinder where the amount of precipitation can be measured. The collector is typically made of fiberglass reinforced polyester for lightness and corrosion resistance. This Indian standard 5225 tells about the collector in details. The bottle is the next part of the rain gauge where the water or rainfall is get accumulated. Here, this is the bottle. The bottle is of different capacities like 2 liters, 4 liters, and 10 liters. One or more handles is fitted with this bottle to keep it out and discharging the water. The bottle shall be completely continued within the base. The mouth of the bottle, this mouth of the bottle, shall not be less than 45 mm in diameter. The rain gauge shall be fixed on a masonry or concrete foundation of size 600 by 600 by 600 mm, which is sunk into the ground. The top 50 mm of the base is exposed or above the ground level. Now coming to the measurement of rainfall, once this bottle is filled with the water or daily at 8:30 a.m. 8:30 a.m. by Indian Standard Times. The water in this bottle is discharged in this measuring cylinder, and the rainfall is measured through this graduation. The observer removes the bottle from the base, pours the water slowly into the measuring cylinder, reads the level at eye level to avoid parallax error, records the value in millimeter, and empties the cylinder. If there is more water than the cylinder can hold, it is measured in multiple pours and added. Care must be taken to avoid any spilling of the water. Even a small loss can lead to underestimation of rainfall. Underestimation of rainfall when the water is being lost while pouring the water from bottle to this measuring cylinder. If any amount of water is lost, then it will underestimate the rainfall. The measuring cylinder is especially designed and calibrated for the collector area of the gauge. Measurements are taken every day at exactly 8:30 in the morning as per Indian Standard Time. The rain gauge shall be protected from being damaged, particularly by the stray cattle, by erecting a fence around the rain gauge, as shown in this figure. The height of the fence should be half than the this distance of the fence and the rain gauge. If here the distance between the rain gauge and the fence is 2.4 meter, then the height of the fence should not be higher than the 1.2 meter, which is this is 2.4 meter by 2 is equal to 1.2 meter. So height of the fence should not be greater than 1.2 meter. The ranges shall be kept logged and periodically painted to prevent its surface from corroding or deteriorating. The amount of precipitation covered by the gauge depends heavily on its location, on how well it shielded from distorting factors like wind eddies, turbulence, splash, and any obstructions. Indian Standard 4986 IS 4986 gives some guidelines to keep or for installation of a rain gauge. The rain gauge must be placed on a level ground. It should not be placed on a slope, terrace, wall, or roof. Measurements are taken every day at exactly 8:30 a.m. in the morning as per Indian Standard Time. And the data is being reported in a form given by Annexure A of IS 4986. This format ensures consistent and comparable records across the stations. These are the few references which were taken to prepare this lecture. Thank you for watching this video lecture on Symon's rain gauge. We covered everything from its history and classification to components, proper installation, exposure rules, daily measurement, and a standard data reporting. I hope this has given you a clear and practical understanding of this important time tested instrument. If you have any questions, feel free to drop them in the comment section below. I'm happy to answer all these questions. Thank you. Jai Hind.